I chose chapter 11. Pretty much in chapter 11, it's basically the methods of control system and how chemicals and sterilization is controlled. So starting off with, we're going to use the sterilization method. And in this method, it's basically like a microbial type of control. And how that is the process, it destroys or removes pretty much all variable microorganisms in this stage, and that includes the viruses as well. Pretty much sterile would be like when everything is free for all. Like there is forms, and this will also include your spores and viruses. There's a lot of medically equipment we use for sterilization, and the reason that is for the heat. We also use sterilization for food packages as well, and with that being used, it's like a physical agent, and that is also called heat. Heat is one of the best ways to sterilize different equipments as well. There are only a few chemicals that we can consider sterile agents, and that would be due to their ability to get rid of endospores. A lot of times, sterilization will neither be physical or practical or necessary, and they will only be a certain amount of groups of microbes that need to be controlled. And those groups will be caused by non-endospores that will begin forming microbes. So basically, sterilization is just will destroy a majority of viruses and variable microorganisms. Then we will switch to the disinfectant. The disinfectant is usually, you can refer this to a physical type of process. As you can see, there's different types of disinfectants. This is basically like a chemical agent. It's another word for disinfectant. It's pretty much set out to destroy pretty much anything, like vegetative pathogens, but it does not kill bacterial endospores. Disinfectant are normally only used with inanimate objects due to the concentration in them, because that will be the effective way to actually be toxic. And it's also toxic to human tissue. It will also remove harmful tissues from humans, and it will remove toxins of microorganisms from the materials as well. So pretty much you can apply 50% of bleach or 5% of bleach, and it's going to disinfect, but it's only going to disinfect certain things. Sepsis. This is pretty much a lot of people has heard of this before, but it's pretty much like blood that is found in like a microorganism and often tissue of humans. The term aseptic will stop the entry or block out the entry of the infectant agent, so it does not insert into the typicids. And then they're going to have to prevent the infection. And how they do that is normally practiced in healthcare. So when you go to like the doctor, they're going to be able to stop this. They pretty much know how to form the sterile part of the antisepsis. Now, bacterial blood will actually destroy bacteria, but it will not harm one that is in the endospore stage, because pretty much it may not be effective to the microbial group. So you have like the endospore stage, and then you have like the bacterial stage. When this part of the bacterial bride is in the bacterial state, then it pretty much will kill it. But if it's like in a type of like endospore stage, like moving on, then it's not gonna be able to touch it. And then there are different types of sections that we can break this down into that kill different things, like the fungicide that pretty much kills fungus, spores, and yeast. And then you have like the virucide that will pretty much be any chemical known to inactivate viruses from a living organism or a living type of tissue. And then your sporicide will be capable of pretty much taking out bacteria, endospores, which it can also be a sterilant due to it can destroy most resistance to the microbes. So the Greek word for stasis and static actually means to stand still. And what that means is they can act or combine together like in a group, and with the different prefixes of all kinds, it pretty much the microbes will prevent from multiplying, but not killed. So it will not kill or transmission. It pretty much is going to leave like different types of sanitations. So when we get to that part of it, then you're pretty much going to have like a technique that mechanically removes any type of debris. So the effects on a cell membrane, what pretty much happens here is a lot of the agents is part of like the cell membrane. So you're going to have like a microorganism will have a cell membrane that are pretty much made of lipids and proteins, with many viruses with an outer membrane envelope. This is a diagram showing the effects it has like on a cell membrane. Detergents are called surfactants. Pretty much will work as a microbial agent. It's a process that opens up one type of surface interface, and it will pretty much leave like leaky spots, and that's what allows damage chemicals to seep within the cell and allow important ions to get out. So the denaturing of protein pretty much is it will occur when the bonds that maintain a normal, like, three-dimensional configuration. So you'll have like a secondary and a territorial type of structure of the protein, and then it's going to be like broken. So within the breaking part of this process of these bonds, it will cause the protein to unfold. And then it's going to pretty much create a random and irregular loops like it's shown in here. And once the loops, it's going to end up being coils. Another way proteins can denature is through like moist heat. And what happens with that is going to expand. And sepsis, which I had talked about previously, but pretty much a lot of people can end up getting this. I know like a few people that's had this, and pretty much what happens is your body breaks down, and the ways to tell if you have it is pretty much like if you're shivering, like freezing or very cold, your whole body's like extremely like in pain. There's no discomfort, and it pretty much feels like you're dying. You stay sleepy all the time. You wake up very confused. You're pretty much like shortness of breath. Your face complexion's very like pale, and your skin's like pretty much like yellowish. That's pretty much like your body trying to break down this virus, but sometimes it's hard without the appropriate medicine and IV that you need to break down the sepsis. Pretty much on this is like the hand scrubbing. A lot of times people that don't scrub their hands, there's like a lot of bacteria on there, which is broke down in like non-germicidal soap and germicide soap within like a couple of days. And it's pretty much like millions of bacteria per liter to scrub water. So it's broke down on how many people have like scrubbed their hands with germicide soap and without. There's like a lot. There's like a big difference there with the hand scrubbing type of stuff. Now soaps, it's like a mechanism. Pretty much with soap, it breaks down like the bacteria off your hands. It's pretty much like an alkaline that are made by combining like different fatty acids into a soap. So you're going to have like the oils in your soap. You'll have like sodium, potassium in the soap. And you even have potassium salt in it too. So like here is like the polar and non-polar on here. And it's like it ends, hydrocarbon ends of the soap molecules in the middle to attach the oil grease particles. So when you have your hands and you're washing your hands with a type of soap, it's going to pretty much attack whatever is on your hands. The most common type that will destroy only highly sensitive types of forms, such as agents. The most common one is the hospital pathogens, and it will be pseudomonas, which is resistant to soap. It will primarily work as cleaning and sanitizing like agents, especially like in your home, hospitals, workplaces.